is our seasoned expert. Like, if you have any AI questions, any like deep, fundamental understanding of concepts, this is the man. Man, the legend. All right, guys. I guess this is a good segue to start the talk. My name is Abai. I've been organizing Austin Deep Learning for like 4 years now. How long has it been? Yeah. About that. If I have to kind of describe myself, I guess I'm an engineer, but not really. I haven't been like a traditional employed engineer for the past 2 years. I've been mostly like traveling around South America barefoot and like doing photography for dating profiles, and then also like helping build startups, AI startups. The last one I built raised like $1 million, and we trained a foundation model with a few hundred GPUs. And it ended up being like its first solution, like first foundation solution in the finance space. But I don't like to be like pigeonholed in one job. I do all kinds of things. And LLMs kind of exploded in the recently. So they kind of diverted from everything I know about deep learning, machine learning. Large language models just came up with their own term, with their own like project. It's a new space. It's completely it's sprouted by itself like literally in a few months, and they came up there. You will see here they came up with algorithms and methods that could be used in traditional machine learning that were impossible before that. So it's really cool solutions. So seeing the enthusiasm in space, it's amazing. So I'm really glad you guys are here. I really want to thank you for participating and making this community dynamic and being part of it. Thank you. By the way, before we start, this is a workshop. So whenever I will be talking about large language models, we are actually going to be trying them. So you could either use a QR code go to the Bitly link. It's bit.ly 4501R0Q. And if your Wi-Fi is not working, let me know. It should be Capital Factory, guess. Case matter?
Yeah. That's
Case should matter, but I guess it does matter. Huh? Oh yeah, here it matters. Yeah, it looks like we're able to fit pretty much everyone. This is very lucky. Wow. So the seating is actually for 50 people. We had over 100 people sign up, like 110 I think. Perfect. Everyone got it? Thumbs up? Yeah, let's wait a couple more minutes. But while I'm going to go on a rant while everyone's trying to get on the Wi-Fi and the Git repository. I'm very thankful for OpenAI. Everyone who doesn't use ChatGPT. You don't use ChatGPT?
I can't tell what version it's running. It claims to be ChatGPT, but it never says what version. So.
Oh, but you use ChatGPT. Yeah. So everyone here uses ChatGPT. Yeah. I know. I use it daily. Like when I'm coding, I can't remember last time I coded without ChatGPT. So it has everyone uses what's it called, the Copilot. Right? Who doesn't use Copilot? Yeah, I know at Apple, they actually restricted. You cannot use Copilot at Apple. And I just met a gentleman from Google. He said you have your own tool for doing the Copilot. But the thing about all these tools, I'm very thankful that they were able to lead the way and come up with all these methods. Like, who would be crazy enough to think, let's just train hundreds of billions of parameters. Let's see what happens. Who's stupid rich enough to do it? So OpenAI was stupid enough and rich enough to do that. And thanks to them, we know that when you train large transformers, you get these amazing emergent features. Who is not familiar with transformers? Who has never worked with transformer models? Okay, who has never like trained a model before? Okay, so we have a good mix. And from talking to you guys, I assume you're gonna be able to follow along. Before we start, anyone has seen any recent cool applications of large language models, like on Reddit or any cool projects that you want to share? No? Okay. One cool one I've seen was, anyone, you guys know reinforcement? Yeah, go ahead.
I think what Khan Academy is doing is pretty interesting.
What are they doing?
But they have a portal where you can go test out this beta application, but they're using it to simulate these tutors
Yeah.
to help people with the tutorials. Like in a classroom, there's like one teacher and like 30 students. So you can chat to this application that Khan Academy has and ask it questions. It even is programmed, or like if you ask it, tell me the answer, it'll say, sorry, I can't, so work it out and I'll help you figure out the steps to work it out, and that seems pretty impressive.
No, that's really amazing. Because like actually when I went to computer science school, I was in college, this was my dream. Wouldn't it be cool, rather than teaching everyone, we would have these special ed teachers that would kind of adjust to your needs, like how I like learn from your feedback. So now we're training them, but in the future they're gonna be training the future of humanity. So this is, you can see like the implications of large language models are fucking amazing. And not, those are high level, like those are like where you use LLMs as agents, so like ChatGPT is an agent where you have a chatbot, but there are a lot of applications of this as an encoder decoder models. So if you're a software engineer, you know a lot of applications. For example, you could use large language models. Looks like, turns out they have amazing representation capacity, meaning you could encode, you could compress information. So they're amazing compressors, and you could put them in what's called vector databases. Who heard of vector databases? Some of you, but vector databases are basically when you get the intermediate representations of your text or data, you could store them in these vector databases, and you could mathematically search the closest part. So you basically could do semantic search on your data. And there's actually, there's a new open source project that I recently seen. You could upload all your documents. Let's say you have some legal documents. You have your customer support data that you've used for a long time, right? And you want to be able to talk to the data, like what are the problems in your customer support. You just dump the data to LLM in a vector database, and then your LLM will be able to index it, and you'll be able to efficiently traverse not just through the memory of the LLM, but through the explicit outside memory in the vector database, which that's amazing. And again, so here are the advantages of large language models. The privacy is, as I was mentioning, Apple does not allow usage of LLMs and code generation tools. So, or for example, you might have very sensitive data, like in a financial world or whatever. You might have some IP data. If you want to be able to have preserve, if you want the privacy, you cannot use ChatGPT. Just by the way, I'm gonna spoilers. GPT-4 in the ChatGPT, nothing beats that yet. So if you are expecting like GPT-4 model performance, we don't have that yet because it uses trillion parameters, which requires around like 40 GPUs just to run an inference. So we're not in the open source world or any private inference world, we're not GPT-4 level yet, but we're getting there. So we are in between GPT 3.5 and 4, but not 4 yet. And flexibility, today I'm going to be showing the things that you cannot do. For example, when I was talking about the vector databases, there are things called prompt tuning, LoRa, all those things. There are a lot of features that you cannot do in, there are a lot of cool features that you cannot do with solutions like GPT or Anthropic or other paid APIs. Money friendly, yeah, so it's, you only need your hardware. Literally today we're going to be using a large language model, and you don't need a server, which is crazy. If you think about it, what we're going to do today, it was unthinkable a few months, like literally science fiction a few months ago, what we're going to be attempting today. We're going to be using like billions and billions of parameter in your tiny little laptop. And this is the biggest part for me, support progress. Although, OpenAI, they've pushed the progress, they pushed the envelope, but they're stagnating it because of monopoly. They're using, like, you have guys have seen, they did a talk at the Congress, right? They were trying to basically lobby, and they're trying to make up these laws to stop development of AI. So in that case, like, only big companies gonna be able to develop. So for you participating in open source and using open source models, it helps the progress happen. So, and recently, the open source world has been full of energy, a lot of amazing projects, a lot of cool stuff happening. It's a wild, wild west, but it's a lot of fun. I had a lot of fun coming up with this talk and looking at all the models. So we're gonna go through a little bit of history. Who has been to Austin Deep Learning before? Right. I know some of you. Yeah, fuck yeah, awesome. Okay, so you guys know we did the BART and BERT paper, we did the GPT original paper. I think we might have done the Codex. Yeah, so when these models came out, right, they were like such a hot new thing, they were a cool thing. And here you could see their family of encoder-only models. They never developed. So the BERT model, the way it worked, I wonder if the marker here. By the way, this is one thing, when you will be going the world of large language models, this is a little bit confusing terms. Encoder only, encoder decoder, decoder only. It doesn't mean architecture-wise, it means task-wise. So it's encoding task, encoding, decoding task, and decoding task. So the way BERT works, just the encoder family works, you might have I to eat apples. You would leave a mask, right? It's one of the tasks. And the model would say, it would try to come up within this sentence. What's this word that we masked out? I like to eat apples. It could be love or I like it. So it will try to statistically model what's that masked word is. So this is the encoder-only model. And what encoder-only models do, they can look both backwards and forward. Right? So the models we're using right now, they are the decoder-only model. Decoder-only model, the way it works, it's I love to eat blank. So it only goes in one direction. The encoder-only models, they work in both directions. So it turns out when you do encoding, it also has, you only need a few dozen or 100 million parameters, and you achieve really good embedding performance, so a good representational performance. But it kind of, as you scale it, it stagnates. And then the decoder-only model, which is GPT, they've tried it in GPT, and they saw that GPT-1, if you guys remember from when we reviewed the paper, it has these emergent features. When you give it a task, it will be able to perform that task just using text. Right? The first time I remember, like, we were reading this paper, I think either, not who was there, he said, no, you don't need to train for this. When someone said that you don't need to train for specific tasks when you're doing a GPT, it blew my fucking mind up. Like, you don't need to train for the specific task because for context in deep learning, we did reinforcement learning, we did classification tasks, we have all kinds of tasks, and you have to carefully design how your model does specific tasks. Like, for example, you could train it to play Atari, but it's specifically Atari rewards, specifically Atari model. It only understands the Atari world. And when the GPT-1 came out, and like they started noticing, oh, you could just come up with the string to do something, and it will be able to finish that. And oh, let's generalize it and make it instructed to do tasks. That was mind-blowing. That was so. We have to thank OpenAI for that. Again, so this is the encoder-only model, and ChatGPT, and all of these are decoder-only. And there's also encoder-decoder, which has some trade-off. I haven't tried Flan. Anyone tried Flan? You all too? Yeah. How was it?
I mean, it's not much better than Flan T5, which is much smaller.
Yeah, T5 is the most popular one.
Yeah, but I mean, it's good. You have to fine tune it.
How many parameters is it?
I think 20 billion.
20 billion?
I think.
Oh, so it's pretty hefty boy. Okay.
I think so. I'll just double check.
Yeah.
But I mean, there's also functionality.
Yes.
Because, like, you can really only use the decoder onlys to, well, decoder onlys generate encoders. You generally make one pass over the input, create an encoding, and then do the they were the original sort of like models used for translation, because you read in all the input and then generate all the output. And encoders only generate an embedding, but don't actually write anything else.
But encoder, decoder, they do both. They encode and also they can generate text. And so one interesting to mention is Bloom. This is an interesting case where it failed. Bloom, it's a science foundation that was heavily funded. It's a non-profit organization. I think it's a big science project. They've trained this model 100, 180, I think, and 300 billion parameters. But for some reason, it didn't perform that well. It didn't compare to GPT 3.5. So the project kind of stagnated. They implemented another version. We did the instruction prompt, instruction tuning, which we're going to be talking about. But it didn't do that well. So we come right now, we're here, it's 2023. In the open source world, and today we're going to be running locally on our machines, our Llama. So Llama is a model by Facebook that was open source, so they actually didn't release the data. They released the code and they didn't release the weights. You kind of have to submit. I actually did. As soon as it came out, I submitted a request to get the weights, but I didn't. It's been how, like a few months. I still didn't get anything. So, but good for us. We had a leak. The weights got leaked, and then that literally that leak from their security, the reason we have the open source LLM world right now. So this Cambrian explosion of large language models you see mostly comes from the leak from Llama weights. And no end of the world, like back in the GPT-2 days, they didn't release the weights because they thought it's gonna kill the world. It's gonna become sentient, or people gonna terrorists start using it to end the world. So nothing like that happened. And it's a much bigger model. And I think the one that got leaked was 60 billion. I believe you could have gotten 3 billion without requesting it. But now all of the weights are available. And thanks to that, we have all kinds of open source models nowadays. So when you go into this world of large language models, these are the main frameworks you're going to see. PyTorch, who has ever worked with PyTorch? Oh, okay, so that's a surprisingly small amount of people. Okay, who has ever worked with Hugging Face? Very same amount of people. So basically, PyTorch is a machine learning library. It's more of a tensor library where you could hook up a lot of mathematical operators, a lot of data, and turn it into tensors, matrices, and do a lot of all these linear algebra calculations. And it will do basically calculate the gradient for you, which is how neural networks learn. Hugging Face, it's an amazing project. Now it's a profitable company. They have this hub where you could release your models. It's not just for large language models, any deep learning, any machine learning. You could go on their websites. As a matter of fact, if you've never been to Hugging Face, go to there right now and check it out and check what kind of models you could run and see what it's about. It's amazing. So it allows, the other thing I love about it, has anyone used Hugging Face transformers? Love it. Absolutely love it because, yes?
What's a transformer?
Transformer is there was a paper in 2017 called Transformers All You Need. Attention is all you need. They came up with a way of doing attention. So it's basically attention mechanism model.
But it's essentially synonym for large language models, though it's more general because you use it.
Yeah.
It's the architecture.
Yeah, so they use this terms for key and query from language translation, and it ended up being useful for literally anything. So, and that's the, if anyone is interested in transformers, we could kind of dive deeper into that.
Yeah, can you just reiterate, what is a transformer?
Transformer is a model that was released in 2017 by Google, and it proposes this new architecture neural networks called attention, self-attention. Well, attention in general, but a lot of the good things come out when you apply the attention to itself. So it's basically a model with attention mechanism. So when you have like text, I love to eat apples, right? It could assign weights when it performs, for example, I love to eat apples. What's the most important
word do you think it's important here? Probably eat, right?
Yeah.
So there's a number here that will be associated with it when you perform multiplication. And smaller number here, maybe a little bit number here, and small number here. So it basically, you know how humans, when we pay attention to the world, we're paying attention to small things. We filter the world heavily. Like we have very heavily biased view of the world. We're always paying attention to small things. Not even explicitly, implicitly, we're always like, our minds are paying attention. It's a specific mechanism.
Is it essentially like pointing out like the key words in a sense?
Yeah. So key components that it can also work not just on specific words, also within the embeddings in its own space. It can focus on its like internal representation as well. Yeah, but basically that's the point. They came up with a really cool way of doing attention. There were actually attention, we had it for a long time in recurrent neural networks, but the way they came up with it was they didn't need a lot of things that old method needed. So it's quite simple. It was very simple. Yes.
So yeah, I'll just add, it's a neural net architecture, but one of the things that let us do is let us scale neural nets up to data center size applications and run massive amounts of data through it. Before the neural nets were serialized, the RNNs, whatever, so this let us build data, and that's really what unleashed us to be able to build these giant nets with giant amount of information. So it's just the architecture, but it made these things much larger.
Yeah, we could actually just do it right now. We're gonna pull up the transformer.
I didn't mean to derail.
No, that's good. That's perfect. Because I didn't know what's the makeup of the audience is gonna be. But this is a good thing. And a lot of people are not.
Electric transformers.
Guys, today we're gonna be talking about electric transformers. Actually, so when the Apple talk came out, everyone has seen the Apple WWDC. Amazing, right? Everyone stopped talking about the large language models. I wanted to scrap the whole talk and just do Apple VR talk.
But did you see that their biggest machine has like 190 something?
Yeah, with a bunch of
RAM?
external accelerators.
No,
What was it? Was it
no.
GPUs? What was it?
No, like
card?
the big Mac Pro, it has like 190 something gigabytes of unified RAM, and that's like the GPU has access to that. So if you want to fit GPT-3 in it, you can.
The M2?
Yeah.
That's amazing, dude. And what I've seen is on their, when you type in Apple, they just use the field, the next word, but I think they start using large language models. They could actually like look at the structure and all that stuff. So so they did use language models. Transformer architecture.
So in that case, it's like in the new way of typing in on iMessage, they're using a decoded model, a decoder model to look forward, right, for the next word.
I'm not sure how they're doing it, but they are using a large language model from.
If it's a model that's spitting text out, then it's generally a decoder. And whether it's just decoder or encoder depends. Like, generally you can do almost anything you can do with an encoder decoder, you can sort of do with a decoder only. But generally if you want to like process the entire input before starting to generate anything, then you use an encoder decoder, whereas if you're kind of typing as you go. So generally things like completion suggestions generally just be decoder only.
So this is the architecture. Everyone can see. This is the original architecture. These are basically what's happening. Every step is a matrix multiply from an input. And if you see an arrow like this, it's an addition. And within here, this is where the attention happens. But it's basically matrix multiplication, addition, matrix multiplication, addition. That's all it's doing. It's just there's a interesting thing. By the way, one note about encoding. This is just came in. Turns out encoding is like positional encoding is not needed. Who knows about positional encoding? Yeah, turns out it only hurts the performance of larger models. So just removing positional encoding is better. This is just the news. Everyone's talking about it in the machine learning community. We could look at the transformers formula.
What's the source on positional encoding exactly, or what?
Oh yeah, I could show positional encoding.
You mean that you don't have to respect the sequence?
Yeah, you don't have to respect sequence. You don't have to explicitly tell it. And it turns out you make it more challenging, therefore it learns better.
feel like the order is kind of important though.
That's what I thought, yeah. But for all, this thread right here. I'll stop using version of coding, but all the respectable scientists commented and tried this out, and apparently that's true. So you don't need version coding. In larger cases, I'm not sure about, because you might need it in smaller models because you need to help out smaller models out.
Define large?
Larger than 13 billion parameters.
Thank you.
I don't remember the formula, so we can just look at it together. So it's basically a softmax of query, and this is the key, and then it's normalized. But basically what it's saying is, in my input, find, see, it's weigh, this matrix multiplication will weigh basically the query, and then that softmax will normalize it. And this is how the attention happens. So that's what transformers are. It's, to be honest, it's quite simple, right? So traditional neural networks, you have simple, straightforward. Here you just have to do additional matrix multiply and the normalization and softmax, and that's a clever way of doing attention.
Maybe we're saying what direction we're multiplying, because it works a little different than it's like a multi-layer perceptron. Right? The point is that for each word, there's like a basic source embedding, which is something like word2vec or something like that. And for each word, you've got really two vectors. You've got the key vector and the value vector.
Yeah.
And then you've got the vector which represents like the state.
No, please.
All right.
I actually love this. Like
Okay.
going back to the basics.
So, for each, all right. So for each word, you basically get two vectors. You get a key and a value vector, and then wherever you're at, there's like a current state vector which represents like where you are in the conversation or in the thing. And that, since you've got one of these key value pairs, you've got for each word. And what it does, so there aren't really, unless you've got actually multiple heads, there aren't really multiple layers.
Yeah.
All you've got is key value, key value, key value for every word in the sequence you've seen so far.
Yeah.
Or if you're in an encoder-decoder, you also got the key value pairs going forward as well, right? And what you do is you take this vector and you dot product it with each key. So you do a dot product, and that gives you a weight. Weight 1, weight 2, weight 3. And then what you do is you take each value vector, multiply, so this value vector times this weight, this value vector by this weight, and then, so you get basically, so the values represent like the meanings of these, and so you basically get like a weighted sum of the meanings of all the words you've seen before, and that is essentially, that is then the input to the next, that basically is your next state that you get.
And then from there you could just decode. And the originally what it was, they had two different languages, two different inputs, and and the key and values were from like translating from one language and then paid to another language, attention to another language. But nowadays we just use it as a self-attention, so you just keys and values, they just look into it as your own input. Okay. So everyone is able to connect to the network, right? Everyone is able to get to the GitHub page. What I want to ask you to do is click on the first link. Let's see. You should be here, and just have this page ready. Make sure it works. I haven't tried using it yet. So what I want to do, we have some. I've selected some open source models. I want us to come up with some tasks for these models together. So we're going to run them, and we're going to run our own tasks that I hope you individually design yourself. And then you're going to evaluate them. You're going to say, hey, this model did this well, like between 1 and 10. You're going to evaluate if it solved your task or not, right? And from this, as a community, we're going to be able to select best open source model basically for us to use that you can run locally, rather than relying on automated or external tools. So we're going to help each other out. So Hugging Face, again, it's a hub. By the way, Guanaco QLoRa is the new model that I wanted people to try out. But I tried it today, it says running, it didn't work for me. So try it out, see if it works for you. But it's one of the evaluations here is Guanaco Simple, Medium, Hard. If it doesn't work for you, it's fine, you could skip it. Anytime model doesn't work for you, you can just skip it in the evaluation list. Let's see. That's But this is what Hugging Face is. It's basically where all the models live. You could push the models, you could use other people's models. It's basically a GitHub for machine learning and AI. Yeah, it's not working for me, so let me know if it's working for anyone else. It has been working. I think they replaced, it used to say running on GPU A100, A10s. I think what happens is there's so much demand right now, the Hugging Face stopping releasing of spaces like this. You used to be able to run any model on Hugging Face, but because of the demand, you no longer can. So, and that's why using the open source models locally can help you, because the Hugging Face no longer provides as much resources for community as they used to try models out.
It worked for me.
It works for you?
Yeah.
Okay, awesome.
What's the definition of working?
So when you type, like here, let's see. So it says error for me. You can chat.
What are you supposed to type?
Whatever you want. It's like ChatGPT. Yeah.
I asked it something and it says error.
Yeah, it said error.
Yeah, I guess
It doesn't work for me.
Just zero and little, so it's already all. Yeah, it goes right.
It's not that good? Yeah, I think they scaled this one down, so we're gonna just, if it doesn't work for you, you can skip the Guanaco, and we'll do it last. But basically, Guanaco is a very new model that came out from this research paper called QLoRa. Anyone heard of LoRa? Okay, I'm gonna explain in a bit. And also, Guanaco doesn't work, just make sure you open the notebook. Who has Jupyter set up locally? So if you want, you could download the notebook and run it on your laptop. If not, you could just open the link here and then click open in Colab.
Should I be opening Colab on my own computer also?
Yeah, because what's going to happen is going to run it in Colab. So it's going to run on the cloud. Because a lot of the models we're going to be downloading, for 13 billion parameter model, you would need around almost 100 gigabytes of memory just to store the weights. But because of the methods like LoRa, we've compressed them down to like 4 to 5 gigabytes. And that's why we're able to run them locally today. Yeah.
Locally, but not locally.
Yeah, locally but not locally. No, it's locally because you're not paying an API provider. And you're just running it on a single machine. So I'm just going to walk you through what these, because when you go into LLMs, these terms are used a lot, these frameworks, and it can be confusing, and I'm going to explain what they are. So PyTorch, you probably won't see them if you're just doing high-level development, but it's when you design models, fundamentally that's what you use. Hugging Face is a higher level, it provides the abstractions on top of PyTorch, like PyTorch transformers. Working with these models becomes super easy. So GPTQ is from a paper called GPT quantization, and it's actually just a technique to quantize, but they made it into a repository, and it's its own format. So if you have a large language model that is GPTQ, it won't work for anything else. And in that repository, Bits and Bytes is just a wrapper around CUDA where you could write acceleration for these models for NVIDIA accelerators. So GGML, so at first it was Llama C++. It was a side project for a guy. It's actually quite funny. Llama C++, CPP. The guy, right now it's one of the most popular ways, 30,000 stars on GitHub, to run these models, because it's purely, they removed all the Python and they purely implemented the models in C++. And it's very blazingly fast. And that's the reason we're able to run them locally. Also, this is the library. And I just wanted to show you the moment. The original implementation of Llama CPP was hacked in an evening. And there's a funny thread here. Has anyone seen this? Like, hey, I was reading your README and I saw your repo was hacked. I want to ask if this means that I want to check if the users like me also get impact of hacking. Yeah, but basically it was just a side project for some guy. And right now it's one of the main tools is in large language models. And like a lot of people in academia, like Stanford, they're using this in their research as well. So it's becoming a production thing. But this guy, Greg, I guess, he came up with a new framework called GGML, and he turned it into a format. So Llama is a subset of GGML. So when you look for models, I highly recommend looking for GGML models because they're quantized, they're compressed, and they're pure C++. And this is fairly new. This is only like a week old. It's called MLC. They're trying to run large language models on embedded devices, which is ridiculous, right? So for reference, ChatGPT-3, it took 2 months, 1,080 gigabyte GPUs, right? 1,000 GPUs, training constantly for 2 months, right? And just to inference it, you needed around 20 GPUs just for inference. Not training, just to actually run it. And the way ChatGPT runs right now, it's also, you need multiple GPUs to run it. But now, you could kind of compress them and run it locally. I wonder if I could show it here. You have the USB for...
What's it called?
It's called MLC AI.
Like C is in the letter C? Or?
Yeah, letter C, MLC, yeah. I actually put it on my phone just in case. I think I could present it here. Quick time. I didn't know, but apparently you could do this. New movie recording. Screen and show up my phone.
I've got a quick question.
Yeah, sure.
Are these accessible through phones or just computers and tablets?
I'm about to show the phone one, yeah.
Oh, okay.
If it shows up here, let's see. It doesn't show iPhone, I don't think. Maybe I could use the screen. It's called Anthony's word.
Yeah, but you saying E echo kilo, or is that what you're saying? Echo kilo as an EK hyphen PLC? Is that what you're saying?
Sorry, what? About what?
Never mind.
You said MLC.
MLC, I guess, yes, MLC. That's I just, this is just, if it doesn't work, it doesn't work. It doesn't matter, but I put it on my phone. I just wanted to show that you can run LLMs nowadays on a phone, which is literally science fiction. Like model was 7 billion parameters on a phone, on a mobile device. It's absurd, it's ridiculous, and it's reality. Let's see here.
They ran one on like a Pixel 5.
Huh?
They ran one on a Pixel 5.
Yeah, they have one Pixel 5 too.
But it's just inference.
Yeah.
So inferencing is easy, training is hard.
Well, I'm going to show QLoRa. You could actually train on the phone too, which is also ridiculous.
Is that what we're doing today or something?
Today we're just going to inference. But anyway, it's not showing. Yeah, doesn't matter. If you just come up to me, I'll show it on my phone if anyone's interested. And LangChain is just it's a very high level wrapper. It doesn't do much, but at the same time it does a lot. It provides this very intuitive interface to language models. So you could, but one problem with LangChain, you have to manually port the model to LangChain, so LangChain can interface with it. But it can do these things where you could manage prompts, you could design prompts, like in ChatGPT, you have to append a prompt, right? You are a OpenAI model that does these things, and you have to be nice to the customer. So you could do all these things here, and you could manage them. The other thing it does, you can, like the vector database what I was talking about, where you could store the knowledge in vector databases. It could automatically basically hook up the vector database and then let the model index it. Yeah, so it's basically a high level API over large language models. I like it a lot, and it's used in research too. So what is this? Let's see here. So I was talking about GPT-Q, which is the state-of-the-art way of doing quantization of networks. But this is literally just a few hours ago, 4 hours ago, there was a paper that significantly beat GPT-Q. You can see the progress, that's very fast. So you should be seeing what we see today in a few weeks is going to be even faster and even better. And another some keywords that you will see. Anyone has ever seen any of this before?
Yes.
Okay, so most of you haven't seen any of these, so I'm not even going to go into the details. Let's start with the simplest one. So you will see COT in large language models used a lot. It's a chain of thought. There was this paper that showed that when you deliberately, logically, explicitly state the problem and then tell the model to solve the problem in explicit ways, you'll perform much, much better. And when you have a data set that is structured in a way where you have step 1, step 2, step 3, it's like, you know, how you're proving, you're doing proofs in mathematics. If you structure your data set in that way, your models will be much, much better, the performance-wise. And then people built on top of that, and they created this tree of thought, which is also interesting, where you have the model, it comes up with its own outputs, and then you use the model itself to evaluate them, and then it goes here, and then starts going with new outputs, and then evaluates. So the model itself generates the outputs and evaluates it, and then it finds the best optimal path to come up with an answer. And you could do it automatically if you have a data set that, for example, mathematics. In mathematics, you have outputs that are always the same. If you're solving a problem, there's always one answer, so it's very easy to solve in that. The other thing is alignment. Alignment has been big in discussion recently. It's how do you get like large language model? Only thing it does is just predicts what's the next token is, what's the next word. Alignment is how can we get them to not just do that, but listen to us and do what we want. For example, find the best Apple product, right? You want it to know that you're looking for an iPhone, that you're shopping, that it's a digital product, or it's a device. It's not like a fruit apple. So you want it to do certain things. Or for example, the big thing right now, existentialists are talking about alignment, is save humanity. So you could save humanity by just not letting them reproduce, just stay them there, like freeze them, and they all would be alive as in this chunk of ice. Or that's not what we want, right? We want to live alive. And so like what happened in Matrix is basically misalignment. So they want to have alignment of the models, performance, and humans' intention. And the way we do that, the simplest way is to instruct. So you have, when you train your training data set, you put an instruction rather than just raw data. Because when we train on raw data, OpenAI went out and they basically crawled the entire internet. When you use ChatGPT, it has knowledge of the entire internet, right? But that doesn't work. What you need to do, you need to tell it, hey, do this. You want it to solve tasks. You want it to learn to do things. So in the data set, you could add a solved math problem, and then as an output, you follow the instructions, right? So you give specific instructions to the model, and then you solve. So it's usually the way it happens. You train a full model, again, which takes thousands of GPUs, and it takes months and months to train, and then you have instruct data set which aligns it. And RLHF is reinforcement learning. Has anyone done reinforcement learning before? Anyone familiar with reinforcement learning? Who is not familiar with reinforcement learning? Okay, so who doesn't want to raise their hands? So reinforcement learning, human feedback. There's a field in machine learning called reinforcement learning, which is based on negative and positive reinforcements. So you have an agent, and you let it perform a task, and you make it either a positive or negative reward. So that's RLHF, it's very hard. Only OpenAI has done it, but recently we only do instruct or DPO, which is direct. And these are, we're gonna skip through this, but anytime you see llama, alpaca, vicuna, guacano, it's just a family of models that came from leaked llama. Red pajamas is the main data set they use for training. PEF is parameter efficient fine-tuning. So when you have a large model like that, you can fine-tune it to your own data set, to your own tasks. And these are the specific methods, which is LoRa, QLoRa, and Bits and Bytes. It's not really a technique, it's the library that we just talked about.
What does LoRa stand for?
Low rank efficient training. Yeah, so I actually wanted, I read the papers. I was thinking for some reason that we're gonna have a lot of mathematicians. And I guess we're not learning to do that. But it's basically, the idea is, I'm gonna go over, LoRa is important. That's the main reason we have open source LLMs. When you have large matrix, where we learn the weights, right? Instead of what you could do, you could have small injected weights, self-adaptable weights that are much, much smaller. The theory, the linear algebra behind it, that it's actually a low rank. So a lot of, in the large matrix, you need the large matrix, but the information that it's stored, it's very low rank, so you don't need everything. So you could basically use low rank vector C's. And when you inference together, you add the output, and then when you do the gradient, you could just tune these weights. So this is what LoRa is. High-level LoRa.
Right.
Yeah.
So when we want to train a pre-trained model,
Yeah.
so this is the way that is usually done?
Nowadays, yes, it's fairly new. It's like a few months old. But yeah, this is the way it's done now. Because if you want to train fully this, like old way, you need a lot of GPUs. You need dozens, hundreds.
When you talk
Yeah.
about it to fine-tune, so I was
Yeah.
thinking, well, do we download all the weights, and maybe we just run some epochs with a data set that we had for the specific task? So that's the way it was done before?
Yeah, the way it was done before, you download all weights, and then you have your own data set, and then you fine-tune, you keep training from the previous epochs. But now, instead of training this, you don't touch this because it's too hard to compute. You use a lower rank matrices that are just injected. And because of this, you have, for example, as I was saying, you will notice 100 gigabyte model could be put like 5 gigabyte to 5 gigabytes. So it's going from this to this.
But then you run both, so you have two models in parallel, and you kind of ensemble the answers or the solutions of the output somehow.
Yeah, so it turns out what you can do, you can just inference this. You don't even need to inference this. You can just inference this at the end. So that's why inference is also fast. And so LoRa, I'm really curious how this will translate in traditional deep learning because I haven't seen it used yet. Maybe because the network's already dense and you can make it low rank. I don't know. What do you think? We'll talk about it later. But I think it's time to kind of go ahead and try the models. So everyone is able to open up the notebook?
Well, we have to open on Colab.
Yeah, or if you have a Jupyter, you could download it and just run in your own Jupyter.
But you said it was too big for our machine.
No, I mean, it depends on your machine. Yeah, by the way, disclaimer, if you're running it locally, make sure you have like at least 10 gigabytes of RAM. You just need CPU, you don't need a GPU. Just make sure you have like 10 gigabytes of RAM. Yeah.
If you're in a Colab, make sure you've got the GPU selected too.
No, not necessarily.
No?
Yeah, so we could just use CPU. But you see, LoRa is they compress the model so much that you don't really need it. But one thing, if you're running in Colab, it only has one core, so it doesn't have the parallelism. But we're going to be using the BLAST. So if you have locally it will run faster because you have multiple. Even if you have like 2-4 cores, we're going to be able to use the BLAST optimization to run it.
Usually, I mean, Colab usually gives you a GPU or even a DPU.
Yeah. But so at first, let's start with CPU because the models here that they were compiled for GGML, but they do not support. So I noted here, it's only CPU here.
Okay.
You can run GPU, but only for these two models. So I want to run these two. Before that, let's get into groups and go back to the page here, and then come up with easy, medium, and hard tasks. The easy task would be like, for example, what's the multiple of 3.1 and 2? Right? It's easy. Medium task would be write a poem about and teach me Python at the same time. And hard would be something like develop, write a website code that does specific thing, right? So just whatever is easy, you think is easy, whatever you think is medium, like fill out this form and just try to come up. You could work in groups, but try to come up with individual responses, okay?
So you don't submit the form now?
Yeah, you don't submit it, you just fill it. The first thing, easy task, medium task, and hard task. Just working groups and just start to come up. Single instruction, right? So it's a model, it's not chat, it's a single instruction, and single response. So that type of task.
But I don't think so.
Everyone got simple, medium, and hard task? Yeah. Thumbs up, thumbs up, thumbs down? Okay, thumbs up.
Companies won't be willing to share the data outside of
Okay guys, so now you have your tasks. Copy in your buffer, just copy your easy task. And then we're gonna go over the notebook. We're just installing, everyone knows pip installed, we're just gonna install the LangChain library, which is the high-level framework for the language models.
So is Colab?
Yeah, pretty much. And again, it just has one port. It doesn't even have a dual port. So now we're gonna install Torch, and we're gonna also install the Llama CPP, which is the Python wrapper around the Llama CPP. And depending, in this case, we'll install it with the cuBLAS. Not cuBLAS, OpenBLAS.
By the way, if you go to runtime, there's an option to just run the
I just want to show them like what. So what we're doing, we're just installing the library.
I know, right? I would struggle with that.
By the way, guys, let me know if any step it doesn't work for you in your Jupyter notebook. Let me know. Just tell me, okay?
Yeah.
By the way, this is important. When you get, after available models, you're going to get to select a model. First, this run, we're going to select a stable Vicuna 13. So the first one, selected from here in available models, the first model. It's 13 billion. It's Caper AI stable Vicuna 13. And you're going to paste it into here, into chosen model. Yeah, like this. Because we're going to be trying out different models. So what we're doing, this you see Hugging Face? We're going to be downloading the binaries that were reduced using LoRa, so quantized into 4 bits. I will explain it in a little bit what it means. But we're downloading these weights that are made for GGML library that I showed you earlier, which is integrated into the LangChain. So we're going to be inferencing using LangChain. So again, run the available models, print the descriptions.
Hold on. Step 3 failed. Step 3 is a disaster.
Where?
Install command doesn't work.
Where?
No, step 3. 3.
1, 2, 3, yeah. Successful install.
Well, what does that mean? Install command, it doesn't do anything.
No, it's installed. No, okay, so here, This is just a trick. If you the shebang means you want to run a bash command, and this injects the Python string into the bash. It's basically easy way to run the Python script in a manner. Yes.
I needed to add words.
Yeah, there it is. Upstairs, but it's some string, putting it in curly, making it up.
He said, he just said this.
Okay, guys. So that's the installation work for everyone. Libraries are installed. Good, good. Were you able to choose the model? Change the model to chosen. Can I get thumbs up? Chosen model? Then you're gonna run wget, which is gonna take a couple minutes.
Very bad.
All's good? Everything's working?
Art is a beautiful but now Python, and I don't, for my job, I switched jobs, so I'm no longer doing data science, I just walk through like just a product. This is way harder than